Hello, I am Brian Corbridge, and this is my presentation on Lab 3 about circuits. So, as a quick introduction, the purpose of this lab is to predict the behavior of series circuits containing resistors. To do this, we will be using multimeters to measure the current and potential differences throughout a circuit with ohms resistors and capacitors. In this lab, we will primarily be reliant on the node rule, loop rule, charge conservation, and Ohm's law. You can see here in the bottom right, this is Ohm's law, and then this is the charge conservation. Our findings from this lab simply just confirmed these laws. There wasn't much statistical findings that are really important, but it did confirm all these things that we are learning about. This lab will be split up into two parts, with one setup dealing with DC circuits and the other dealing with RC. This first circuit is dealing with DC currents. Um, so for this, we duplicated the setup seen in the diagram up here in the top left. And we did this using this set of wires, ammeters, resistors, and yeah, when we used the ammeters to measure the potential differences across each resistor. We expected the current at each ammeter to be equal to 2/100ths of an amp, and for it to read the same when the flow direction was reversed and the positive and negatives were switched. Um, while the latter was true, it was equal when the flow was reversed. We found each ammeter to read 19 thousandths of an amp. Since there was only one path for electricity to go, we knew that the current had to be the same across each resistor. The second part of the same circuit, uh, we swapped out one of the ammeters for a voltmeter and then used it to measure the potential difference across each portion of the circuit. Using this method, we were able to find the current in the circuit by adding all of the potential difference readings. This summation gave us the same 19 thousandths of an amp that the previous method provided. This is because the voltmeter has such a high resistance that almost no current goes through it, thus not altering the readings of the ammeters. Now we're going to be focusing on our RC circuit, which is the second of the two. For the RC circuit portion of lab, we investigated the charging and discharging of a capacitor and recorded the time it took for each process with different levels of resistance in the circuit. For a resistor of 1.5 ohms, we recorded that it took 10 seconds for the capacitor to charge from zero point 0.1 volts to 2 and 14 seconds to discharge the same amount. When we swapped out the resistor to a 5 ohm light bulb, those same measurables took 42 seconds and 60 seconds, respectively. After plugging these results into the conservation equation, we learned that the experimental time is significantly longer than the theoretical expected time for such discharges. Um, this is the conservation equation I was talking about here that we put it into, and this is a little diagram of the setup we were working with for the RC circuit. So here are my final thoughts on it. I'm going to start with the theoretical posed questions in the lab assignment. So if we charge a capacitor with no resistor in the circuit, then the capacitor should theoretically charge almost instantly. When we attempted this theory, uh, when we attempted this theory in real life, we could not confirm that this happened instantly, but the amount of time that it took to charge the capacitor was so small that we have no real measurements for it. So from naked eye, it was seemingly instantly, but uh, we cannot confirm this with 100% confidence. Lastly, it's important to know that not our it's important to know that our experiments were not executed to perfection, and these shortcomings may influence our results slightly. Such deficiencies included stopwatch clocks that started and stopped at the power of human perception, so time was not perfect. As you can imagine, someone trying to start and stop a stopwatch, um, when they see certain numbers on the multimeter, it's not going to be perfect timing for that. Additionally, we did not include the resistance of the wires in any of our models. they do indeed offer some sort of resistance, not a lot, and if we did include it, it'd be a very slight change to our numbers, but there there is some resistance within the wires. It's not a perfect wire.